So there are 2 rules left, and they're shorter. And we're getting close to our time, so we have more art. How did chemistry change history? We talked about how it changed prehistory and natural history. How did it change history? Well, it turns out that the humans, we used elements in chemical order as well. It's not just biology that used them in chemical order. But then something different appears to have happened. We changed the world with them. So here is another redox potential graph, but it's with metals that you can mine out of the ground, and it's reversed. Because when you're mining something out of the ground, you have to pull it out of the ground, and that's different chemistry from the chemistry of it being released. And if you look at this, if you arrange all these metals by redox potential, the ones with the more positive redox potential, well, here, there's gold. And gold was probably the first metal to ever be used in its pure form. These other ones were, with the higher redox potentials, were used earlier. And then when you get to the ones with the negative redox potentials, that's magnesium, which wasn't even used till the 1800s. And I want to point out chromium, not used till the 1800s, is also on this end of the scale. So it's like as we moved through history, we got better at chemistry, and we were able to move more and more down this redox potential arrow and release these metals and use them. And this had a direct impact on art. So you can see the periodic table in yellow pigments. The first yellows were all minerals. And if you look at these, you see arsenic, sulfur, lead, this tin, and antimony. That's where you know you have a degree in chemistry when you can recognize that one, because it's really weird. If you find these are all on this part of your periodic table. There they are, right there. And so it's like these all made the ancient yellows, or the older yellows, that were refined over time. But those are the yellows that we were able to pull out of the ground. One major life yellow was an Indian yellow, which was made, a carbon pigment made from cow urine that you fed mangoes to. I don't know how they figured that one out. But it also fades like these other ones. These other ones don't fade, but they're toxic. So these all have drawbacks, right? Well, in the 1800s, the chemists isolated chromium for the first time. From chromium, you can make chrome yellow, and you can make it cheap. And therefore, Monet used it a lot. Nice, bright, cheap yellow. It is only possible because a chemist isolated chromium. Chromium is also in green viridian, and you see the date there, 1859. So this had lots of impacts, and colors is actually where chemistry starts. The chemist Bayer, you might recognize that name from a pharmaceutical company, figured out how to make indigo from regular chemicals. And that had a big impact because it broke the British indigo monopoly and won him a Nobel Prize, by the way. Economy, science. So just like we made new yellows, we also made new blues. And remember that blue is really expensive. But everyone wants blue. The sky's blue. We've got to find a better way to make blue. Well, a better way happened by accident. Somebody added cyanide to a red lake pigment prep. So mistakes are okay in chemistry, especially in labs, apparently. That made Prussian blue. And about 100 years later, cobalt blue and French ultramarine were synthesized. About 100 years after that, indigo was made. That's when Bayer made the indigo, and they made other blues at that time too. With each of these discoveries, the price of blue pigment dropped, and even Monet, starving impressionists, could use it. And you can see it in their paintings. So you can make that judgment based on a life of looking at art, or you can make that judgment based on a computer looking at paintings for you. I think looking at art yourself is probably more rewarding, but the computer is a little more thorough. So we told computers to look at art and add up the colors they had in them. And this is from 100,000 images that the computer looked at, and it added up the colors, and you see the blue, there's more and more blue as we get closer and closer to 2010. In fact, if you just separate out the blue by itself up here, this 1, 2, 3 is where the different blue pigments were invented. And you notice a little bit after each one was invented, boom, your blue goes up, your blue goes up again, your blue goes up again. When the pigments got cheaper, the chemists gave artists new colors. And there's one other really weird way that metals make colors. This was found by accident. Nanoparticles. Nanoparticles sounds really modern, but it's actually found in medieval stained glass. They happened upon it. They added some gold and some silver as they were making some glass, and it turned red and yellow. The reason is, they didn't know this, But now we can look at the glass and we can see that the red glass with gold in it has these tiny gold particles. Very, very small, nanoparticles. And so the medievalists made the red and the yellow there. And now we can make different shapes of the different particles. And we can mix them in glass. And now we can make green nanoparticles, yellow nanoparticles, etc. But that's really kind of cool. And nanoparticles have some really weird properties. Here's a cup made from silver and gold nanoparticles. And it's red, right? Until you ignore the sign that says no flash photography. You take a picture of it with a flash, and it's green. Same exact cup. But the way it interacts with light is different because of the way the nanoparticles work. So the thing is, if the medievals could make it by accident, you can actually make it yourself in the kitchen. And I have 4 different recipes, 4 different ways to make it, that you can start with gold, copper, or zinc and make nanoparticles that do different things. This is a picture showing how tea leaves can do it. They can turn a gold solution into gold nanoparticles. And the cool thing is, the longer you run that, the bigger the nanoparticles get, and you get different colors. So the one thing I want to show you about that is that if you get different sizes of gold nanoparticles, you'll have these different colors that result. So now we can control this process much better, but it really is an old process, and it really can be seen when you go into a medieval cathedral. So we mined the elements out, we changed the world with them, we did science and art, and we put the two together, and new things happened, and nature itself changed, or some say that maybe you should say nature began when humans became conscious.